Hi everyone, I'm Vipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I'm going to talk about one topic in coordinate geometry, that is collinearity of points. How to prove that 3 points are collinear. There are two approaches through which the collinearity can be proved. One, using the distance formula and the concept of triangles. Second is using the area of the triangle formula and again using the concept of triangles. Let's talk about the first approach. Approach 1, using the distance formula. Let's look at 3 points. Suppose there is a point A, there is a point B, there is a point C. Now, if these 3 points are not collinear and you just connect these 3 points, then they form a triangle. Okay. One property of the triangle is that you add any 2 sides of the triangle, the sum will be greater than the third side. So, for example, if you add AB with BC, then this will be greater than the value of AC. Okay? And that is true for any combination of sides. Meaning thereby that if suppose you add BC and AC, then that also will be greater than the remaining point AB, and likewise the third combination also. Okay? That is the property of a triangle. Okay? But let's extend that concept a bit. Now, if suppose we bring this point a bit closer to this line. Suppose we have brought it here. Then also this will form a triangle, and then AB plus BC will be greater than AC. Absolutely okay. What if we bring this point exactly on this line itself? If that is the case, then AB plus BC will become equal to this entire length AC. And if that happens, then you can notice that it is no longer a triangle. Point B also comes on this line AC itself, therefore it is no longer a triangle. So if you happen to find that the sum of the 2 sides is equal to the third side, then it means all 3 points are collinear. So let us try about this problem which is given. The problem given is determine the points A, B, C. A is 3, 1, B is 6, 4, C is 8, 6, whether they are collinear. So let's try that. Suppose these are our 3 points, A, B and C. A is the given point which is 3, 1. B is given point 6, 4. C is given point 8, 6. So what will be the value of AB? AB will be equal to the square root of x2 minus x1, that is 6 minus 3 the whole square, plus y2 minus y1, which is 4 minus 1 the whole square. This becomes equal to 3a square plus 3a square, which is equal to the square root of 9 plus 9, 18, and this can be then written as, because 18 is 9 into 2, Therefore, it can be written as 3 root 2. Okay. Likewise, let us find out BC. So, BC will be equal to, again, a square root of, now x2 minus x1 is 8 minus 6, the whole square, plus y2 minus y1 is 6 minus 4, and that is whole square. So, this becomes 2 square plus 2 square, which is equal to 4 plus 4 is root 8, and root 8 can be written as 4 into 2, a square root. So, therefore, this becomes equal to 2 root 2. Okay. Let's talk about the third one. Third side is AC, and AC will be equal to this length is, if I am treating this as A and C, so this becomes the second point, this is the first point. So then 8 minus 3, the whole square, plus 6 minus 1, the whole square. So then this becomes equal to 8 minus 3 is 5. So it is 5 square plus 6 minus 1 is also 5. So it is 5 square. 25 plus 25 is 50. 50 is 25 into 2. Root of 25 will be 5. So this becomes 5 root 2. Okay. Now let's try the concept which we had just talked about. Let's look at this. I will just rub this thing. Okay. Now let's see. AB plus BC. AB is 3 root 2 plus BC is 2 root 2. So we can write this as root 2. You take common 3 plus 2. So we can write it 5 root 2. We are noticing that AC is also 5 root 2. Therefore, AB plus BC is equal to AC, and therefore all 3 points A, B and C, A, B and C are collinear. So this is one approach of proving collinearity. Let's talk about another approach, which is using the formula of area of triangle and also again related concept of triangle. So let's look at that. This is approach 2. So whenever we talk about area of triangle in coordinate geometry, you will find that the relationship of finding the area of the triangle when 3 points are given is this. The area of triangle ABC, which has 3 points, A x1 y1, B x2 y2 and C x3 y3, then the area of triangle ABC will be half of, under bracket, x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. Okay. So we will make use of this formula. Now let's try drawing the same triangle ABC which we had just discussed. Suppose this is A and this is B and this is C. Now another way of looking at this problem is that if this point is here, the triangle is having certain area, let's say this A1. Okay. Now if suppose we take a call that, okay, let's bring this point closer to the line AC. Suppose we have brought it here. So if we have brought it here and we draw the triangle again, Naturally, just by the view you can see that the area is reduced, means A1 is certainly greater than A2, right? A2 is lesser than A1, okay? Now, if we extend the same concept further, the area will further reduce, meaning thereby that if we bring B very close, then area will be further reduced. What if we bring the B completely on this line? Let us see. If suppose we bring B completely on this line, what happens to the area of the triangle? That area becomes 0. Okay? So we will use this concept. If we find that the area of the triangle using the triangle area formula in the coordinate geometry is 0, it means all 3 points are collinear. So let's try about this combination of points. So if I have to find out the area of the triangle formed by these points A, B, C, then I'll have to use the formula, which is half of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. It is easy to remember half multiplied by x1 y2 minus y3, 1, 2, 3. x2 you have taken 2 here, so it is 3, 1. And then x3 you have taken 3 here, then it is 1 and 2. It's like this, 1, 2, 3. And then you start with 2, 3, 1. And then you start with 3 and 1 and 2. So it's a kind of cyclic in order for 1, 2, 3. Okay. So let's try putting the values. Now you can write this as half of, what is x1? x1 is 3 multiplied by y2. y2 is 4 minus y3 is 6. Okay. Plus x2. x2 is 6 multiplied by y3. y3 is 6 and minus y1. y1 is 1. Okay. Plus x3. x3 is 8 this case. And y1 is 1 minus y2 is 4. Whenever you are putting the values, be careful and cross check once again, because majority of the students commit problem in putting the values. Okay. x1 is 3, so it's correct. y2 is 4 and y3 is 6, so this part is correct. x2 is 6, y3 is 6 and y1 is 1, so this is also correct. x3 is 8 and y1 is 1 and y2 is 4. So the values which we have put is correct. So this becomes equal to 3 times minus 2 plus 6 times 5 plus 8 times minus 3. Okay. So then you get minus 6 plus 30 minus 24. So you are getting then half into this minus 6 and minus 24 is minus 30 and this is plus 30. So you can write half multiplied by 0, which is equal to 0. Since the area is equal to 0, it means all these 3 points are collinear. So you can prove collinearity with either of these two approaches. Hope you understand it and you will enjoy solving problems like this.